Good evening, all of you. I hope I'm audible. Good evening, Shailesh sir.
Good evening.
Sir, we will be waiting for a few more minutes to participants to join. I have sent a reminder too. So, dear participants, we'll be starting the session very soon.
Yeah, sure.
Good evening, everyone. So, let us start the session as it is 6 p.m. A very warm good evening to one and all present here. We welcome you all on behalf of the Department of Computer Science and Engineering, TocH Institute of Science and Technology, Kochi, Kerala, to the inaugural ceremony of the 6-day AICTE ATAL sponsored online faculty development program on Next Gen Intelligence, HPC, Applied AI, and Data Science. TocH Institute of Science and Technologies and Engineering College, which is established in 2002, and we offer several courses in BTech as well as in MTech as well as MBA programs. Our FDP session started yesterday, and yesterday we had the inaugural session at 6 p.m. And then we started with the first session, which is handled by Mr. Praveen. That's 1.5 hour session, and following that, we had the session by Mr. Sherry from Gadgeon Systems, and finally we could wind up on time by 9:30. So thank you participants for joining the session, and we'll be starting today's session right now. So over to the coordinators to start with the session.
A warm good evening to all. On behalf of TocH Institute of Science and Technology, it's my great pleasure to introduce our resource person, Dr. Shailesh Sivan, to this meeting. Dr. Shailesh Sivan is a distinguished technology evangelist, educator, and researcher with a rich blend of academic depth and industry expertise. He currently serves as a principal AI architect at Lennox AI India Private Limited, a UK-based company, while on academic leave from his role as an assistant professor in the Department of Computer Science, Kochi University of Science and Technology. Dr. Shailesh held a BTech degree in Computer Science and Engineering from Kerala University and an MTech degree in Computer and Information Science from CUSAT and an MSc in Mathematics from the University of Madras. He earned his PhD from the Department of Computer Applications, CUSAT, for his pioneering research on AI techniques for analyzing classical dance. With over 9 years of experience in teaching and research and 5 years in the IT industry as a senior software engineer, Dr. Shailesh brings an exceptional blend of theoretical knowledge and practical insights. His expertise spans across diverse domains of artificial intelligence and data science, including deep learning, computer vision, machine learning, natural language processing, data mining, soft computing, quantum computing, and knowledge graphs. A passionate researcher and academic leader, he currently guides 4 PhD scholars as recognized research supervisor under the Faculty of Technology, CUSAT. His academic excellence is further demonstrated by his multiple qualifications in UGC NET and GATE. Dr. Shailesh is an author of a widely acclaimed book, Algorithmic Thinking with Python, which has sold over 3,000 copies and is celebrated for its practical approach to algorithmic learning. He has published over 50 research papers in reputed international journals, conferences, and editor volumes, and hosts two granted patents in AI applications. As a passionate knowledge disseminator, he has been a resource person for more than 150 workshops, seminars, and invited talks empowering faculty, students, and industry professionals. He is actively collaborating with industries and government organizations as a technology consultant, providing strategic direction in architecting and deploying cutting edge AI driven solutions. Dr. Shailesh Sivan is committed to shaping the future of AI and technology research driven by a mission to contribute meaningfully to the evolving digital world. Welcome, sir, for this meeting.
Thank you. Thank you for the introduction.
Shailesh sir, you can share your presentation.
Okay. Yeah. Is my screen visible to you? Hello?
Yes, sir.
Yeah.
Visible.
Okay. So, first of all, good evening, all of you, and I would like to express my gratitude for inviting me as a resource person for this second day of very important FDP on next gen intelligence, HPC applied AI and data science. And I would like to extend my congratulations to the Department of Computer Science and Engineering, TocH Institute of Science and Technology, for taking an initiative for such a wonderful FDP. And on the second day, we are actually starting with the natural language processing and generative AI in the context of the next gen intelligence. you're all aware about how natural language processing and generative AI is actually going to transform the future technology landscape. So I'm having an attempt to make you understand what are happening in the field of natural language processing and how this natural language processing is extended to achieve what we are seeing as a chat GPT or a Gemini kind of LLM applications. Okay, so this is not a technology or a theoretically rich presentation. Instead, I'm just giving you a very surface level or a layman perspective of explanations to make you understand the concepts well. Okay, so starting with natural language processing. So, in natural language processing itself can be viewed as a branch of artificial intelligence that gives machines the ability to understand natural human language. And if you think about the technologies of natural language processing, we can actually relate some other technologies like you maybe heard about computational linguistics, text mining kind of uh, domains that is having a very relatable overlapping with this particular technology landspace. So, what is actually natural language processing? As I explained, it's actually a branch in artificial intelligence that gives machines the ability to understand natural human language. Okay, so uh, what, as I said, it is a branch of artificial intelligence, right? So, what all ways the artificial intelligence will help us, or what is the core features of artificial intelligence? What is the capabilities of artificial intelligence? So, when we are looking into the definition of artificial intelligence, it's actually a technology that deals with making intelligence to systems or computational systems with the help of data and algorithms. Okay, with the help of data and algorithms to make the systems enable with three major aspects. The first one is to to make decisions. Okay, then to do perform optimization and even to generate contents. Okay, so where we can actually place NLP in the domain of artificial intelligence. See, as I said, it is actually a subset or a branch of artificial intelligence where this intelligence is generated with the help of textual data and information. Okay, with the help of textual data and information. Okay, and that is we are using the intelligence making techniques that can manipulate and understand textual data and information by machines. So the major focus is the machines will get an ability to understand human language, the natural human language, and to respond according to the input. Okay, so why we need to build such a domain, subdomain like natural language processing? Because we know billions of text data being generated every day, and most of them are unstructured. So we should have an automated technology with intelligence to process this unstructured data and to find out the useful insights from it. Okay. And when it comes to natural language processing, we particularly perform two different task that is called as natural language understanding and natural language generation. Okay, natural language understanding is nothing but if a user is giving an input in natural language, the system should understand what it is and respond to it. Okay, right? Like say in a Alexa kind of application. Okay, we are actually telling like Alexa just play a song, right? And by understanding that, by Alexa, please play a song. By understanding that, it is taking an action to play a song in an application, right? So it is particularly we are giving voice as an input, but after that voice getting accepted, the system will translate that voice into text, and then only it is getting processed. So there it is it is actually understanding the natural language instruction and responding to it, right? And when it comes to natural language generation, what is it? See, when you use Google Translate, okay, what is happening when you're using Google Translate? When you type an English sentence, and if you select the target language as Malayalam, what will happen? The English text will get understand, and it will get converted to the other language called Malayalam, right? So there, after understanding, there's a generation process is happening, right? Generation process. So that kind of things are actually happening in natural language generation. Okay, hope you understood what is natural language understanding and natural language generation. Okay, so what all use cases we can actually leverage the advantages of natural language processing, or what are the applications of natural language in different domains. See, the major applications we always focus is machine translation. Machine translation is nothing but it is to translate a text from one language to another language. Okay, and information extraction is the other another application where if you have a proper bunch of text documents, from the text document we have to retrieve the very relevant informations. Okay, and the next one is sentiment analysis. Based on the contents within a text, we have to classify a text as a, say, sentiment value. It can be either positive or negative, or it can be a polarity, whatever it is. So we are actually mapping our textual data into a sentiment value. And information retrieval is another kind of thing, as what we are actually seeing in Google search engine. Like we are searching for a particular uh, context, and Google will understand and it will retrieve all the relevant information for you. Okay, and the question answering systems are like the chatbots. Like if you give a question as an input to the chatbot engine, it will generate an output based on the question. Okay, so hope you understood what all things are happening in the natural language processing, right? So machine translation, information extraction, sentiment analysis, information retrieval, and question answering. These are the things that are uh, that are majorly implemented by leveraging the potential of natural language processing. Okay, and when it comes to implementing this natural language applications using Python, there are a lot of tools available, and the major tools are NLTK, Natural Language Toolkit, Genesen, Text Blowback, Spacey. Okay, so if I get time, before we winding up, we can actually go through some kind of implementations too. Okay, so what are the common terminologies within natural language processing? If you are trying to build a natural language application, what all things you, or what all steps you actually need to perform in a usual way. Okay, so there are different kind of segmentation techniques: segmentation, then word tokenization, then stemming, lemmatization, stop word analysis, dependency parsing, and part of speech tagging. Okay, so I'm just going to explain these things in a very detailed way. So, what is segmentation? Sentence segmentation is nothing but, see, if you are given with a particular text, okay, a text, the sentence segmentation divides the entire paragraph into different sentences for better understanding. Okay, see, the input text is hello world, the blog post is about sentence segmentation. It is not always easy to determine the end of a sentence. One difficulty of sentences periods that do not mark the end of a sentence. Example, and ex dot is abbreviations. Okay, so after processing this text using an intelligent sentence segmentation technique, we can see that it is split into different sentences like hello world. This blog post is about sentence segmentation. It is not always easy to determine the end of a sentence. One difficulty of sentence segmentation is period that do not mark the sentence of a sentence, and ex dot is abbreviations. Okay, so what what is the real focus? If you have an input text, we have to split that text into different sentences. Okay, and the next step is, after getting a single sentence, the next step is tokenization. Okay, so in tokenization, we break the sentence into separate words or tokens to understand the context of the text. Okay, so it need not to be a word, it can be a punctuation, it can be some other representations. Okay, so whatever it is, see, the example says, we love NLP. Okay, we love NLP. So after tokenization, word tokenization, we split that we love NLP into we love NLP and exclamation. So the entire text is split into four tokens. Okay, the three of them are actually words, and the one is actually a punctuation. Okay, so we have now discussed about sentence segmentation. After that, tokenization and stemming and lemmatization. Okay, so when it comes to stemming and lemmatization, both are actually focusing on finding out the root word of a particular word. Okay, particular word. Maybe like suppose if I am walking is the sentence, its root word is walk. Okay, steamer, then the root word is steam. Okay, likewise, we have to find out the root word of a particular word. So stemming cuts off prefix and suffix. Okay, if we are giving the input like unable, okay, unable, it will cut off that un, and we will it will give the able. Okay, unnecessarily. Okay, unnecessarily. So it will cut off both un and necessarily ly, and it will give the output as necessary. Okay, so it will cut off prefix and suffix to reduce a word into its root form called the stem, and it may not be a valid word in the language. Okay, so sometimes, as it is not an intelligent technique, stemming will result on some word which may not seems as a word itself in the language. Let's see, example, the changing, changes, changed, and changer is converted into chang. E is not there. Okay, but the same process, but the lemmatization will perform this process with more intelligence. Okay, so it reduces words into their base or dictionary form known as a lemma. So not stem, it is actually lemma. Okay, so lemma will be more accurate or more seems like a word in the language or a dictionary. Okay, and it uses some kind of intelligent mechanisms to to make this perfection. Okay, and some kind of networks called WordNet. You maybe heard about it. There is a knowledge base called WordNet, English WordNet. Such kind of WordNets are actually used by this lemmatization technique for effective uh, lemmatization process to achieve a good lemma for a particular word. Okay, and the next one is stop words. Stop words are nothing but they are words that so widely used and they will not carry a very little useful information, and or we can say it is not at all relevant for a particular context. Okay, so what we will usually do is, if there are stop words within the input, we will find out that stop words and remove it from the text. Okay, so a, I, off, on, for, with, the, at. There are a lot of stop words corresponding to each natural language. In English, there is a collection of stop words. In Malayalam or in Chinese, everywhere we can find a group of stop words. So what we will do usually is, from the given text, we will simply ignore or throw out the stop words for keeping only the most relevant keywords according to the context. Okay, and part of speech is nothing but, we know, for a particular given language, we we can actually identify them as grammar words, right? It may be noun, pronoun, verb, adverb, adjective, preposition, conjunction, interjection, like that, right? So if you are given with a particular sentence, mapping each of this word in the sentence into a particular part of speech tag, it is actually called as POS tagging. Okay, so here you can see, I like to read book. Okay, I like to read book. And here the output of POS tagging is, I is mapped to a preposition, like is mapped to a adverb, to read the books to nouns. Okay, also we can actually something called dependency parsing too. While finding out this particular post part of speeches, we can also find the dependency between each word too. Okay, and this is a very particular application called as a named entity recognition, and this is a very needed one to, even in the time of ChatGPT or Gemini kind of LLMs also, we are using this NER kind of applications very widely as a pre-processing thing. Okay, so what is named entity recognition? It is nothing but the process of identifying and classifying key information called as entities, such as name of people, organization, locations, dates, and more, within unstructured text. Okay, and this is a very challenging task too. And even you can build your own named entity recognition for particular application. You may be build a named entity recognition for a medical application. There you can actually tag the elements in the text as the medicine, okay, or the drugs, or you can build it, you can find an entity like a disease, a prescription, or a subject. This kind of things can be tagged. So for each particular application, we can actually build our own named entity recognition techniques. Okay. So so far, I think you could understand. Is there any doubt in the topics we have discussed so far? To make it interactive, can you just put an S on the chat box if you are understanding the things properly? As I'm not seeing your faces, I wish to get a response from your side. Make understand.
Okay, sir, I think everyone is responding with an S.
Yeah, okay. Thank you. So we are moving to the next phase. That is, after the topics we have so far discussed were you usually used as a pre-processing stage. Okay, pre-processing stages. So after doing all this pre-processing, the next thing we are actually trying to do is the feature extraction. Okay, We know for performing any kind of machine learning task, whether it is image or text or whatever data, whatever type of data, we need to extract the features. Okay. And what do you mean by feature? Can anyone tell me what is a feature?
Actually, sir, feature is some characteristics of any text or something like that, sir.
Yeah. So can we call it as an attribute?
Yeah, we can say it is an attribute also because attribute is actually giving some values to some objects or something, entities, right?
Okay. So yeah, that I want to just make that clear. See, this confusion is always there with everyone. That we can we consider this attributes as a feature, okay, or every attribute of an object become a feature. See, there is a confusion that suppose we consider a student as an object, okay, and we want to predict whether the student will pass the exam or not. And when we look into the attributes of student, the name, the age, the roll number, the department, the semester, the IQ value, the rank of the student, how much time he spent for studies, all these things are actually attributes, right? But can I say all these attributes can be a feature for this particular problem? Is it possible? Will the name, age, and department of a student contribute to for making the decision of whether the student will pass the next exam or not?
No.
No, right? So that is the major difference. That is, every attribute cannot be a feature. A feature can be an attribute. Okay, feature can be an attribute, and that attribute should particularly contributes towards the decision making problem currently we are interested in, right? Then only we can consider that as a feature.
अबे यार यहाँ भी खोद दिया
Participants
कुछ
have
काम धंधा नहीं है
okay.
Participants, please mute yourself.
Okay. So, and see, problem to problem, this feature will also change. That suppose if I ask you like what are the features I can consider for classifying the images of apple and banana. There is So particularly, we can say like the color of the color from the image, the shape from the image, and or texture from the image. These things can be considered as a feature for classifying the images of apple and banana, right? But when it comes to apple and tomato, what will happen? Will the color help us? No, right?
No, sir.
No. Will the texture help us? No. Will the
No.
shape help us? No. Right?
No.
So the previously these are all features, but now it become not a feature. So according to the problems, the features will change. Right? But fortunately, in natural language processing, most of the tasks we are dealing with can use the same set of features. Okay, the same set of features. So how we can actually extract text related features and what all things can be text related features. So the first thing is, see, if you have a sentence, okay, if you have a sentence, this is a sentence, how can I represent it as a vector? Okay, how can I represent it as a vector? See here, the quick brown fox jumped over the brown dog is converted to a vector 1 4 13 9 5 2 1 13 23. So you may be wondering how this is possible, right? So what we can do, and converting such a text information into a length feature is actually called as feature extraction. So turning a text into features that can be then fed into a machine learning model is a classical way. that process is actually called as text feature extraction. And usually, what are the major techniques we use for text feature extraction? The major native techniques are bag of words, term frequency, inverse document frequency metrics, and word embeddings are the major techniques. And as I said, fortunately, in the case of natural language processing use cases, mostly all of these feature extractions will work for different use cases. Okay, but in the case of image processing, it is different. Suppose you want to do a classification based on colors, you need to extract RGB features. You want to classification based on shape of a particular object within the image, you need to go for other kind of feature extraction like hue moment or histogram of oriented gradients. And if you want to classify based on the luminance, again we can consider some other features. Or if you want to make classification based on textures, you can go for GLCM kind of feature extraction techniques. So for different use cases from images, we need to use different feature extraction techniques. But as I said, in the case of natural language processing, it is fortunate that we can make use of the same feature extraction technique for different kind of application. Okay, so if you think about different use cases in natural language processing that can be done with machine learning, what all things will come there? What all things? Any one or two use cases can you mention? Any,
Understanding sentiments.
yeah, exactly. Sentiment analysis is one use cases. Then text classification, topic modeling. These things are actually kind of machine learning techniques that we can apply on textual data. Okay, so and particularly this ngram is actually an auxiliary operation we use along with this feature extraction, because this ngram, uh, the idea of ngram is to combine the consecutive words together for giving more context to the processing, right? See, like the engrams are the combination of multiple words used together, the consecutive words. Okay, so engrams with n is equal to 1 is called as unigram, n is equal to 2 is called bigrams, and n is equal to 3 is called trigrams, and so on. It can be a generally engram. So this is big data AI book. So if you consider unigram inputs, unigram as a engram technique for this data for processing, we consider each entity in that text as this is big data A and book. But if you consider bigrams, we will consider two consecutive words together. So this is one entity, is big is another entity, big data is another one, data A is another one, AI book is another one. And maybe in diagram also, it can be like this is just big data AI, data AI book. Okay, so this is an auxiliary operation we use before feature extraction. Okay, and see the next word is bag of words. Okay, bag of words, or we can call it as a term frequency metrics too. See what here what we are doing is, see, we will be having a corpus. What do you mean by corpus? A collection of all documents are actually called as a corpus. Okay. And what we are usually doing is, on getting a particular input corpus, okay, we will identify the vocabulary in it. What do you mean by vocabulary? The collection of all words within that corpus is actually called as vocabulary. Okay. Now, what we will do is, e- we will create a matrix, and each in that matrix, each column will represent each word in the vocabulary. Okay, and each row will represent each document within the corpus. Okay, so by considering one document, here the one document about the bird, and the vocabulary is here in the entire corpuses about bird, herd is the word and you, right? You can see the frequency of each word will be marked as an entry in this matrix. Here, about is present one time, bird is present five times, zero, the herd is present zero, and is present 0, the is present 2, word is 0, and you is 0. And similarly, we will fill the entries for the you heard the bird and the bird is the word. Okay. So after this, you can consider see each sentence or each document as a fixed length vector. This sentence is represented as 1500200, 1500200, and this will be taken as 1110101. This will be taken as 0101210, right? So every sentence or every document will get converted into a fixed length vectors. Okay, hope you understood, right? Bag of words. And see here, what we usually do is we represent this bag of words as sparse matrices, because when you see this matrix you can see most of the entries are zero, right? So we need not to waste the space for storing this matrix, so we usually keep this matrix as a sparse matrix. As we are having an entry at 2 here, we keep 0 7, that is in the 0th row, 7th column we have the entry 2. In the zeroth row, third column, we have the entry 1. In the zeroth row, fourth column, we have the entry 1. Likewise, we keep it as a sparse matrix. Okay. You know what is a sparse matrix. Okay. And see what is the limitation of bag of words. Okay. And in while embedding the idea of n-grams 2 with bag of words, what is the thing, what is the changes you can observe? Okay, see, if you simply consider the sky is a beautiful, the sky is blue and beautiful, the king is old and the queen is beautiful. Love this beautiful blue sky and the blue beautiful queen and the old king. Okay, so this is the bag of a matrix for this particular thing. Or you can simply think like I'm telling two sentences, uh, like I am walking through the bank. Okay, I am walking through the bank and I am walking to the bank. Okay, so almost the vector seems similar, right? Through and uh, to is different, but these are all two different contexts. One is the bank of a river, and other one is the bank that are meant to the financial institution. But if you consider the vector of these two sentences, it seems very same, right? So what I can do for that? Usually we will consider the biograms as a single column. Instead of taking each word as a column, we will consider biograms and unigrams for making this paragraphs. So what will happen is the matrix entries will change for each document in the corpus. Okay. So if there are conflicting documents which is having the same set of words but different contexts, you can make use of diagram or diagram techniques for creating the diagrams. Okay. And see the next limitation you can actually find is there is a similarity in the matrices. Okay, there's a similarity in the matrices, even if we are having uh, same words with different contexts. Okay, same words with different contexts, and the overall importance of a word is not at all preserved within the document. Within the entire corpus is not preserved. Okay, so some words may occur very frequently in one document, but that word may not be an important for the entire corpus. And some words will occur at once for each document, but it will present on the entire corpus, right? So the word level importance towards the document also need to be considered for representing a vector, right? So for that purpose only, we are considering the term frequency, inverse document frequency metrics. So the term frequency is nothing but the number of times a word appear in the document and the ratio of the count of words occurs in a document and the number of words in the document. That is term frequency. And the inverse document frequency is measure of how common or rare a word in the entire corpus of document. And IDF of a word T represent the ratio of number of documents in the corpus with the number of documents with word T in the okay. So by multiplying these two matrices, term frequency and inverse document frequency matrix, you will get a new matrix, that is term document matrix, inverse document matrix. Term document, inverse document matrix. Okay. So for that, TF-IDF is calculated as TF into IDF. Okay. So after getting the data, we will get reprocess the text for extracting the final important words. After that, we will find out the term frequency and inverse document frequency metrics. Okay, so this will help us to keep importance of each word towards the document as well as the corpus. So this is another matrix, and this is a simple calculation of how we can perform this. See here, you can see that the word cheaper is both in the text, right? Cheaper. So the word cheaper is having equal importance in the board document. Okay, and the word petrol is also there in both, right? Okay, so the petrol is also having the same value, right? The car is a very, very particular word repeated two times in document 1 but not at all in document 2. So according to document 1, car is more important for decision making. So in car, see the document 1 value for car in the TF-IDF matrix is more, and as it is not there in document, it is 0. Okay, so not only the presence of word, but also the frequency of words within the document is also important. Okay, right? So the diesel, the cheaper, and the petrol are common in both the documents. The cars are actually repeated. So if I tell you, like, if cheaper is repeated two times within this second document, can you just tell me what will be the change you can observe in the values? Which value will get decreased and which value will get increased? Can you tell me? Any idea? If diesel or if cheaper is repeated two times, any idea? If cheaper is repeated two times, what change you can observe in this matrix? If cheaper is there two times, okay, two times, and cheaper is not in the first, you can see the same value of 2.8 for this document 2 for the cheaper. But since it is distributed over documents, there will be a value for cheaper in document 1 and document 2, and comparing these values, the document 2 will be having more value for what? The word cheaper. Okay, the word cheaper, but it will not be as much as 2.8. There will be some value which is less than to point it. Okay, so likewise, it will keep both the importance of a word towards a document and how much it is important towards the corpus. Okay, and the last technique we are using for representing the textual data for the most modern algorithms are called as word embedding. Okay, word embedding. So, what is word embedding and what is the importance of word embedding? It's nothing but see a technique that represents words as a number so that computer can process them. Okay, so here the word, a single word is represented as a vector and capture the semantic and syntactic relationship between text and represent them in the form of vector, and the similar word will have minimum distance between their vectors. Okay, similar words will have minimum distance between their vectors. Okay, so the idea of the vector word embedding is we have to represent each word in our corpus as a point on an particular n-dimensional space. Okay, that is a vector actually, right? N-dimensional vector. Okay, so here you can see that each word is represented using three values, right? So each word will be a point on a three-dimensional space. And while converting this into a three-dimensional space, okay, what we have to keep in mind. Okay, the Cardinal will win the World Series. We have converted this into the 3D vectors, right? So, what should be the consideration we have to do? And before discussing that, you have to keep in mind. See, for converting this words into vectors, we usually use a particular kind of machine learning family of algorithms called neural network. We are actually going to discuss it. Okay, and in word to vec is a very famous word embedding technique which uses neural approach for generating word embedding. It uses two techniques: continuous bag of words (CBOW) and skip graphs. Okay, and see here is the technique. See, the sun is brighter and the weather is pleasant. Okay, so we will consider a word. Okay, we will consider a word and window size. Okay, two, and since the window size is two, we while considering a particular word, we have to consider the two words left and two words right. Okay, so the by taking the two words to the right is sun is. Okay, and while considering sun, the two words are not there, but one is left, right? One is in the left, so D will be there. East right will be the right side. Okay, and while considering east, particularly we have two words the left and two words in the right. So the sun is actually on the left, and the bright and is the right. Likewise, for each word, we will consider the left and right uh, words according to the window size. Then see the neural network based algorithm. Okay, continuous bag of words predicts a target word. Okay, predicts a target word given its surrounding context words. Okay, that is if you are giving vt minus 1, vt minus 2, vt plus 1 and vt plus 2, we have to find vt. And the skip graph will predict surrounding words based on a specific word called the target word. That is VT given, it will predict VT minus 2, VT minus 1, VT plus 1 and VT plus 2. Okay. So after considering the data we created in the previous exercise, we use that data, that particular data, right? First, we will give this as an input and predict this as an output. In the next case, we will give next the input we will be given this case, the output we are expecting is okay. So whenever this particular neural network is trained with minimum error on prediction, and finally this will be able to predict a predict an embedding for a particular word. So this is how the word embeddings are actually getting used. And after getting the word embeddings, the that word embeddings can be directly given into any machine learning task. Okay, so as I said, what is the property of word embedding? It should keep the contextual and syntactical relationship, right? So, what is your idea? If I consider three words, okay, a forest, a shelter, and home, okay, word embedding of which two words are will be more similar? Which two words? Maybe you can put on the chat box. I think, or you can unmute and tell.
The, sh- the shelter and home.
Yeah, definitely shelter and home, right? Why it is shelter and home? They are the synonyms, right? Synonyms, or they can be used in the same context. Okay, so the word embedding will keep the relationship between words in such a way that if the synonyms words are there, their similarity will be high. Okay, synonym words are there, their similarity will be high. Or if we are using the words in the same context, then their similarity will also be high. The antonyms are there, the similarity between those two words will be very less, right? Like the home, house, shelter, mansion will be having the same same vector in the sense the similarity between the vectors of these words will be high. And if you are considering the words like king, queen, uh, prince, princess, uh, crown, throne, kind of things, these words are actually used in a same context, right? So the similarity between the vectors representing these words will be very high. But if you're using the two words bad and good, their similarity will be very less. Okay, hope you're getting it right. So word embedding will help us to represent a word as a vector, okay, word as a vector by preserving the syntactical and semantical connection between the words. Okay, so even if while training a particular problem, okay, even if while training a particular problem, you can see that one particular word is not at all present in the training, but since it is considered as an embedding, the similar words or the embeddings for the similar words are enough to get make the model understand for this new word. Okay, so the embedding will help us to learn from the data in a very versatile way. That is, we can cover the context and the syntax and the semantics of the language in a very proper way. Okay, and by connecting all these things, this is the usual way we build a natural language understanding or a machine learning or a generation pipeline. Okay, so this is a simple example of text classification. So here, first we will get the text, we will tag them, then we will extract the features, then we got the features, then we will pass that feature extraction to machine learning algorithms, and based on the input it will be able to classify it. Okay, so this is the working. So outline of NLP taxonomy. So what all things are actually there in the NLP? If you simply look into the fundamental techniques we are using, it can be a rule-based method, the linguistic knowledge, regular expression, parsing, encoding, and all. And if you're looking for a data-driven technique, it can be based on probability theory, statistic, machine learning, neural network, and particularly recurrent neural networks and other transformer kind of techniques. Okay, and the tools, the NLP tools We considerations can be the tokenization, the stemming, normalization, tagging, syntax parsing, word sensitive disaggregation, language models, task specific machine learning techniques, or there are LLMs that we are currently using. All these things can be NLP tools. And what the applications we can build is the automatic correction, completion, NER, relation extraction, topic extraction, text classification, sentiment analysis, text clustering, text summarization, text similarity index, information retrieval, question answering, chat based agents, text generation, automatic translation, profiling. These are all applications we are building with the NLP tools and fundamental techniques. Okay, so how all these things are actually working? As I said, there are rule-based method which particularly use regular expressions or linguistic knowledge or parsing kind of steps for natural language processing. Okay, and can you tell me one example that comes under rule-based methods and by which technique we can do it? Any NLP technique? Anyone? Very usual technique is there. While doing the form registration, online form registration and all, we always deal with a particular NLP technique that particularly use the rule-based method. And if I give a clue, a regular expression based method, anyone?
Auto-filling, sir.
Autofill,
So tokenization.
tokenization, that's a pre-process, a complete task. Email ID validation.
Validations of the field, sir.
Yeah, email ID validation and field validation techniques are actually built based on the rule-based techniques, right? The regular expressions and other parsing techniques were used for it. Okay, and when it comes to the statistical applications, NLP models, see the different based on different techniques. We can actually do the part of speech tagging, machine translation, named entity recognition, then text classification and sentiment analysis, topic modeling, and the techniques used can be HMMs, hidden Markov models. Okay, then conditional random field and latent discriminant analysis kind of things can be used for statistical NLP model, but they are all very naive techniques. Okay, very naive techniques, and we are not at all using such kind of techniques as it is having so many issues in implementation. Okay, and see, this is the HMM model to translate a text into part of speech. Okay, and this is something to something that uses statistical machine translation to convert one language to another language. Okay, but the robustness and the efficiency of these methods are very less. And the next level of techniques are usually using machine learning for uh, the intelligence. Okay, and we know what is machine learning, right? The learning is any process by which a system improves performance from experience. Okay, and it can be considered as the machine learning can be technically considered as machine learning is the study of algorithms that improve their performance P at some task T with experience E. So it can be considered as a well-defined learning task given by PT. And for making it more clear, I'm just giving this definition for machine learning. Like machine learning is the process of where a computer uses data to learn hidden pattern through a through an machine learning algorithm, and output of this learning is a machine learning model that can make predictions on new data. Okay, so I will just make you understand with it by opening a particular question here. See, like if I ask you, If 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, 5 is mapped to 25, 7 is mapped to 49, what will be the mapping of 10? What will be the mapping of 10? You can put on.
100, sir.
Yeah, everyone is very quickly saying that it is 100, right? But I never revealed the relationship between the first number and second number to you, right? I never said, but instead I have given some samples to you, the 5 samples. So what happened in your brain? How you are able to tell me the 100 is the output? From the given data, your brain is doing some kind of analysis, right? And as a result of that analysis, you are able to find a pattern that connects the first number and second number, right? What is the pattern? The first number is squared to get the second number. And by using that pattern, you are able to answer the question as 10 is mapped to 100, right? This is what happened in your brain, right? Exactly, this is happening in the case of machine learning. So I have given you a data, and by analyzing the data, and who is analyzing it? Your brain is analyzing it, right? Right? That brain is actually our machine learning algorithms. And the examples I have given is our data. So from the data, the brain or the algorithm component within your brain is analyzing the data, okay, and it is coming up with a pattern, right? That pattern is technically called as a machine learning model. Okay, machine learning model. And using that model, on giving a new data like 10, you are able to predict what? You're able to predict the output as 100. That is the predictions, right? How you are able to connect what is algorithm, what is a model, right? So ML model is nothing but it is the outcome of a learning process. And for learning, we need data and algorithm. And algorithm is nothing but it is a way to find the model which is described or developed with the help of a theoretical foundation. Okay, so that is what we are calling as a machine learning algorithm, and it can be relied basically upon any statistical methods or mathematical model, information theory based model, whatever it is. There will be a particular uh, theoretical foundation for a machine learning algorithm, and with that theories from the data, the machine learning algorithm will find out a particular pattern. That pattern is called as what? A machine learning model. And with that model, a new data is applied on the model, and it will make the predictions on the new data. Okay. So if you think like, if you have a recipe and if you have the ingredients and you are actually creating a food, right? So the ingredients is the data. Okay, ingredients is the data, right? And the recipe is the algorithm, and the food is the model. Okay, are you able to connect with it? Do you understand what is a machine learning algorithm and a machine learning model properly? You can put an S on the chat box if you're getting it properly.
So everyone is responding with us.
Yeah, yeah, thank you for it. Okay, and but and one clarification I need to make here is, see, the example I have properly given to you for making it understand is not a proper machine learning task, right? Because the relationship there was very crisp, like the second number is exactly the square of first number. But if I asked you the question in a way that one is mapped to one, two is mapped to 4, 3 is mapped to 8.9, 4 is mapped to 16.2, 3, 5 is mapped to 25. What will be the mapping of 10? What will be the mapping of 10? Is it possible to tell me, like you did in the previous case?
It's not possible, sir,
Yeah,
because we
that
can't
is
make a pattern.
yes, because it can't make a pattern is not actually the reason. The reason is it is having a kind of uncertainty in the problem, in the relationship, right?
Okay, right, sir.
Yeah. So the major things we have to keep in mind is for applying machine learning, the first point is the problem should be involved with an uncertainty. Okay. And you know, most of the NLP techniques are actually having an uncertainty, right? When a user is writing some kind of data, there will be definitely some kind of grammatical mistakes, spelling mistakes, context confusions, like kind of stuff, right? And from all these confusions only, a system should understand what they are actually trying to input, right? So it is having uncertainty. A text related technique is always having uncertainty. Okay. And even in that uncertainty, we should be able to find a hidden pattern. Okay, so I couldn't say that the first number is squared to get the second number, but I can say the second number is somewhat very nearer to the square of the first number, right? So even though there is no exact relationship, some pattern is there in the data, some pattern, and that pattern is able to get approximated to make a generalization, right? We are able to approximate that pattern to a generalization, and after that, with the generalization what is the quality of the generalization? The generalization should give us minimum error on prediction on the unseen data. Okay, so if you are choosing a problem to be solved with machine learning, you have to keep in mind these are the properties possessed for that machine learning problem. Otherwise, it won't be a useful problem that can be solved with machine learning. See, if I
Excuse
say,
me, sir. Sorry to
yeah,
interrupt. So,
yeah,
is
yeah, tell
this
me.
is an example of a data with hidden patterns? That means
Yeah,
we need to extract the pattern from these type of
yeah,
problems.
yes, there is no exact
Okay.
relationship, but there are
Okay.
hidden relationships there.
Okay. Right, sir. Now
Yeah,
completely fine.
yeah.
Understood.
So when it comes to a lottery draw, okay, a lottery draw. Suppose you are having the data for the past 100 days. You have the lottery draw of a particular lottery. Okay, predicting the next lottery draw is a machine learning problem or not? Predicting the next lottery draw is a machine learning problem or not? Or is it suitable to solve with machine learning? I'm just asking about the perceptions from your side, not the exact answers. You can think and tell me whether the predicting the lottery draw is a problem that can be solved with machine learning or not. You can either tell yes or no.
Somewhat, sir. Yes.
Okay, so make it more clear. See, the first property, that is, that problem is having uncertainty, right? We don't know what is the draw, right? And when it comes to the second property of a machine learning problem, will you be able to find a hidden pattern from that? From the 100 rows, will you be able to find a hidden pattern for that? From that? Definitely no, right? We cannot find a natural pattern within that row. 100 rows, right? Even if it is 100 or 1000 or lakhs of rows we get, we cannot find a pattern there. So that makes that problem not suitable for machine learning. Is it clear why it is not a machine learning problem? Right? And when it comes to prediction of weather with the past 10 days weather, Suppose you want to predict the temperature of tomorrow and you have the temperature details of or the weather details of past 10 days. Is it a machine learning problem?
Yes, sir.
Yes, that is a machine learning problem. How? It's involved an uncertainty, right? We cannot exactly say what is the next problem, right? What is the next temperature, next day's temperature exactly. But even though it is not exact or it is having uncertainty, you can actually find a natural pattern within the temperature for the past 10 days, right? Then that pattern can be learned with a machine learning model, machine learning algorithm, and you can create a model and you can make use that model for prediction. Hope it is clear, right? Right. So keep in mind, almost all NLP problems are actually having this nature, and that is why the machine learning is suitable for applying it on a on a NLP problem. Okay, and if you look into the pipeline of a machine learning technique, it is very much similar to what I have explained previously. We will be having raw data, that is our natural text, and then we have to make it into prepared data, and the prepared data is nothing but the feature we are extracting from the text, and that should be applied on a machine learning model for a particular task, machine learning algorithm for a particular task, and it will come up with a machine learning model. Then that model can be further used for any application. See, machine learning pipeline for an NLP technique. See, we have the raw text, okay, and we can perform pre-processing and normalization like tokenization, standardizing, stop word, punctuation, stemming, lemmatization, and so on. So you will get a normalized data, and by using any kind of feature extraction technique, you can make use of bag of words, CFIDF, word vectorization models, or CNN, whatever it is. Any feature extraction model can be applied. Then you will get the set of features, and that features can be applied on any supervised or unsupervised machine learning technique depending upon the task we have. Okay, so here, see, here we are trying to build a model. Okay, build a model based on the tweets for an airline. Okay, for predicting the sentiments. Okay, so here the raw documents are there. It will get tokenized. Stop word removal will be there. Stemming, normalization. After that, you will get a pre-processed tweet. Then it will get applied into a TF-IDF factorization. Then they are applying the decision tree technique for classifying it as a good positive feed or a negative feed. Okay, hope you understood how we can model this NLP problems as a machine learning pipeline, right? And for understanding the further advancements in the NLP domain, you should understand about one of the prominent machine learning family called as artificial neural networks. Okay, artificial neural networks. So artificial neural networks are a kind of neural network, a kind of machine learning algorithm, sorry, machine learning algorithm that are inspired from biological neural neurons or nervous systems, okay, and or how human brains are actually working for a particular decision making, okay, and how the mathematical theory foundations like linear algebra and vector calculus can be utilized for effectively building such a systems, okay. And the one of the most simplest neural network algorithm or the neural network model is nothing but perceptron. Okay, perceptron. Okay, perceptron can receive these inputs. That is the features. Okay, features. We have mentioned about the features, right? So we can accept a feature vector, and based on the learning process happening in the neural network, it can actually get tuned in a way that for a given feature vector, it can predict the output according to the task. Okay, and well, there are a lot of limitation for this model because this model is particularly based on a linear transforms. Okay, so it can only handle linear problems, linearly separable problems, and that linearly separable problems are very less in actual scenarios. Most of the problems we are dealing with will be a nonlinear problem, and to tackle that nonlinear problem, we have to use the modified version of this perceptron, which is called as multi-layer perceptrons. There you can see the input layer and output layer as such, but in between this input layer and output layer, there are many number of neurons aligned as layers. That layers are actually called as hidden layers. And the responsibility of that hidden layers is to handle the non-linearity. Okay. And it is actually based on a theory called universal approximation theorem. That is, the structure of a multi-layer perceptron is suitable for approximating any kind of nonlinear continuous function. Okay, nonlinear continuous function. So this is very much suitable for learning any nonlinearity in the data, and it uses a particular kind of uh, learning algorithm called back propagation learning algorithm for for the training process. That is, if there is an input at x1 and x2, and we are expecting some output at the y, but the neural network will give some other output as y. So the expected and the obtained output will be having some error, right? Based on that error, it will correct the weights within the neural network in such a way that ultimately, after the training process, the output predicted by the neural network should be same as that of the expected one. Okay, so that is what we are calling as the neural network training. Okay, so the by using the neural network model, we can actually perform different natural language techniques. This particular technique is representing a classification technique, that is, after converting a particular text into a vector. It can be an embedding vector or a TF-IDF vector, whatever it is, that is given as an input for the input layer, okay, input to the neural network, that is a multi-layer perceptron. Then it will predict whether this text is positive, neutral, or negative. Okay, positive, neutral, or negative. So here we are using simply the multi-layer perceptron for understanding the context within the input data, right? And this is another use case, that is on giving a particular input. Okay, it will convert it into embeddings, and this will be used along with the multi-layer perceptron for predicting the next word. Okay, for predicting what the probability for the next word. Okay, so that is what we are calling as language model, a neural language model. Okay, so so different kind of tasks can be realized with the simple neural networks itself. Okay, but there are a lot of limitations for this, and that is why the deep neural networks were evolved. Okay, so the deep neural networks are a variation of multi-layer perceptron. So you can see the figure, right? The one is a simple neural network or a shallow neural network, and the other one is actually called as a deep learning neural network or a deep neural network. What is the difference you can actually understand from this? What kind of difference you can actually observe from this? In the second architecture, there are more number of hidden layers, right? Okay, there are more number of hidden layers. So that is what make the second network a deep neural network. If a neural network is having more than three hidden layers, we can actually put that in the class of deep learning neural networks. It is not a strict criteria that it should have more than three layers. Okay, but most of the time, the scientists who are experienced the nature of deep learning if we put more than 3 hidden layers for a neural network. Okay. And the other advantage of deep neural network or a deep learning process is that, as I said, in the machine learning pipeline, the major hurdle we always face is the feature extraction. Okay, feature extraction. But in deep learning, what is happening is you can directly give your input to the network. Okay, you can directly give input to the network. The feature extraction and the classification process, or the feature extraction and the learning process will be implemented or will be realized by the network itself. Okay, it is the responsibility of a network that it should find the it should find the relevant features from the input and make use that features for the classification type. Okay, hope it is clear, right? So what makes a deep learning model
Shraddha ma'am,
what
kindly mute.
yeah, what makes a deep learning technique unique? It is having a deeper way of learning process, and also it is having a major advantage of automatic feature extraction. Okay, with these two techniques we can say that the neural networks or the deep neural networks family actually transform the NLP domain in a very abrupt way. Okay, see how we can actually handle NLP with deep neural network. See, this is an example of what kind of dynamics is actually a NLP data is having. Okay. See, if I simply tell you, like I'm, I'm talking, I'm thinking about a sentence, and within that sentence, the words I, terrorism, India, love, hate, and is there. Okay. Can you tell me whether I'm thinking about a positive sentence or a negative sentence? Is it possible to conclude? Is it possible to conclude?
No, sir.
No, definitely no, right? Because if I think simply think like I love India and hate terrorism, that is particularly positive. And if I think like I love terrorism and hate India, that is very unfortunately negative too, right? So what is important here? The time dependent arrangement of each tokens are important, right? And that arrangement will give entirely two different contexts, right? So that is what we are calling as temporal dynamics within the text data. Okay, temporal dynamics within the text data. And these temporal dynamics can be viewed in signal data or can be viewed in the genomic data. Everywhere we can see the sequential data is always having that temporal dynamics. And particularly in the case of text, this temporal dynamics is very, very important too, right? So this temporal data can be handled with a very special neural network called recurrent neural networks. Okay, recurrent neural networks. So usually what we are doing is we will be having the text and we will do some kind of pre-processing. It is only pre-processing. We won't do any kind of feature extraction here. Then we will give that into a particular neural network, and that neural network is responsible for making the embeddings corresponding to the words and handling the temporal dynamics, and finally use that context for sentiment analysis or classification or whatever task it is. Okay, and that type of neural network that can handle the temporal dynamics is actually called as a recurrent neural network. What is that? Recurrent neural networks. Okay, and with this techniques, we can do sentiment analysis, text summarization, question answering, machine translation, a lot of tasks. Okay, so what is actually recurrent neural networks and how it works? So when you look into the recurrent neural networks, okay, it is same as that of a multi-layer perceptron, but the thing is, see, the context from one input is actually passed as a input from the input to the next token. Okay, so we will be thinking that the context from one input, that is one sentence, is passing to the next sentence. Not actually, that is not actually right. The context from each token in a single input. The context from each token in a single input is passed to the next one. Not about the context from one sentence to another sentence. It is about context from one token within an input is passed to the next token for processing the next token. Okay, right? Because these images are always misleading, that one input is given, then getting the context, and this is given to the next input. That is not right. Suppose we are having two sentences. I love India. Okay, I love India, and my mother is sick. Okay, so the context from I love India is not actually passed to my mother is sick. That is not right. How the temporal dynamics is happening is, first it will process I. The context of I is passed to process love. The context of both I and love is passed to process the India. That is actually happening, right? Once that is one more processing is happening in token wise when it comes to recurrent neural networks. That is particularly called as time steps. Okay, so you can see this. On seeing this, you can actually understand it as we are simply giving what time is it as an input, but it is actually getting processed as what the context of what is passed here by processing time. The context of what and time is passed to here is to process is, right, and the what type is passed to the, the, this node for processing it, and context of what time is it is passed to process the question mark, right? So this is happening, then only after completing this question mark only it will go to the next layer, right? So the thing you can observe here is what time is it, right? What is there, then on getting time it will get replaced, half of it replaced with time, then is, then it, then question mark, and on reaching this point you can see that the context related to this particular what is very 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 less. That is, after each token getting processed, the node is actually forgetting the importance of the first word, right? That is what we are calling as a recurrent neural networks, and due to this problem the recurrent neural networks are not suitable for l- preserving long context. Okay, not properly suitable for long context. See, just understand, this is the process happening. The first input will be there, and the output from the first input will be kept as a what context here, that is n context will be kept. So along with this n inputs, it will also pass this context towards the next layer. Okay, right? And this will happen for multiple words. See, the one input is coming, the previous context will get concatenated, that is together processed and getting the second context. This will be again given as the input towards the next cell. That cell will concatenate the current input with the context, and it will get processed through the neural network. Like this will happen for all the tokens within the network. And as I said, this kind of neural networks, that is recurrent neural networks, are having a limitation of keeping the large context window, right? That is one of the major disadvantage. And to rectify that issue, there is another kind of recurrent neural network is introduced, which is called as long short-term memory. Okay, long short-term memory. That long short-term memory is actually having a special mechanism to forget and remember the relevant words or relevant tokens within the inputs. Okay, so that it can forget all the unnecessary things and only keep the necessary stuffs. And most use cases, NLP use cases, we will be using this long short-term memory as a tool for handling the temporal dynamics within the text data. Okay, and using the LSTM and one of the RNN family. See, we can give the text as an input. It will get passed to the LSTM layers. Okay, it will get passed to the LSTM layers. And finally, from this point, okay, it will get connected into a fully connected network, which is same as that of uh, a multi-layer perceptron. With that, we can perform the classification. Okay, see here, my grandfather cooks something meals. Okay, each token will get processed by the LSTM at each time step, and it will get passed into the next LSTM layer for extracting more context, and finally the context learned from this point will be passed to the fully connected layer for the classification technique. Okay, so this is how a recurrent neural network family algorithms or family models can be utilized for text classification. Okay, and the text classification also involves sentiment analysis. Okay, the model classification, topic modeling, a lot of things can be done with this uh, recurrent neural network family. Okay, and I'm just mentioning about the spatial data too, because the images are actually coming in the family of spatial data. Instead of the temporal dynamics, they are keeping the spatial dynamics, because to understand the entire thing, what we need is we have to mention, or we have to process this input based on the correlation between different pixels, nearby pixels. Okay, so the spatial arrangement is more important. Then we will call this as a what? Spatial data. Okay, so images are actually an example of spatial data. And to handle spatial data, we have a particular kind of neural network called convolutional neural network. Okay, convolutional neural network. Okay, so for handling temporal dynamics, keep in mind we have RNN family, particularly LSTM or simple RNN. And for handling the spatial data, we have deep neural networks, which is called as convolutional neural networks. Okay, right? And we can perform classification, segmentation, localization kind of stuff with the uh, convolutional neural network for different vision application. Why I am telling this is sometimes the NLP applications also need to handle the vision data for better processing. Okay, so this is why I put a full stop for explaining the deep learning methods used for uh, natural language processing. And now we are moving into the generative AI aspects. Okay, so what is generative AI? As you can see in the figure, generative AI is actually a subset of deep learning. Okay, subset of deep learning. Okay, and technically or more mathematically, if I explain, in discriminative models like classification, regression kind of stuffs are performing, we usually try to find out a conditional probability that for a given input, what is the probability that it belongs to a particular y. Okay, what is the probability that it belongs to a particular y? That kind of conditional probability is actually learning from the data in the case of discriminative model. But in the case of generative model, instead of finding out a conditional probability, we will try to find out a joint probability where particular output from the workshop is actually taken from the probability distribution of that x itself. Then what is the advantage? We can actually create a y which is very similar to x. Okay, so that is more a mathematical declaration. I will try to make you understand with a very simple example. See, suppose you're having the image of a dog, and the neural network models are used to predict whether it is a dog or cat. What kind of technique is that? Is that a generative technique or a discriminatory technique? Particularly, it is a discriminative one, right? It is making decisions on the input. I got a question in the chat box. We can actually discuss it in the last part. Okay. Okay. And generative model, sir, actually see if you have the image of a puppy, okay, and after 5 years, what will be the appearance of that puppy? There, instead of making a decision, we are generating an output, right? We are generating an output which can be uh, very relevant for this. Maybe you are using that nano banana application currently we are using, or the what that image, I just forgot that name. Ghibli image generation or face app kind of things. These are all examples of what, like, generative models. Okay. And when it comes to NLP, see, on giving a particular text, whether it belongs to food or sports or politics, that is news article classification, the topic model. Okay. What is that? This is particularly a discriminative model. But if you are giving a particular input document and summarizing it, what is happening there? It is nothing but we are generating the output based on the input document, right? So that is a generative model. So how these generative models are actually getting worked? There are a lot of techniques: encoder, decoder model, generative adversarial networks, transformers, vision transformers, diffusion models are there. So the basic and very useful one model is deep auto encoder, that is an encoder decoder model. And the idea of encoder decoder model is nothing but, see, is there any question from the participant side? Divya KB. Okay. If it is not, yeah.
Sir, I think we
I
can
think,
move on.
sir,
Ah,
it's by
accidentally.
mistake.
Okay, okay, fine. Yeah. So encoder decoder model is actually a very useful model which consists of an encoder and a decoder. I can relate it with a very simple example. Suppose, see, how you are actually learning an essay for an exam and how you are writing at the exam time. Maybe the essay will be spanned over 3 pages, right? And you are actually going through all the text through the 3 pages. And the question is, are you keeping the same exact words and sentences which is written on the textbook in your mind? Is that happening?
No.
No. We will be keeping the overall context of that essay in some other representation, right? That representation is actually called as code. And on getting that code at the time of examination, what we are doing, we will be using that representation to recreate or to decode what is the actual text, right? And that part is called as decoder. And once a neural network is capable of doing that encoding process and the decoding process correctly, and to make it correctly, we will do the learning process. Okay, make it correctly. What will be the advantage? We can actually represent any input in a very smaller form, and from that smaller form, you can actually create the required output back. Okay, so this is actually called as the encoder decoder model. Okay, so for handling images, as I said, whenever we need to handle an image, we can make use of what, convolutional neural network, right? So here one RGB image is there, and the output is actually the segmentation, that is also an image. So what kind of encoder decoder can be used? The encoder should be a convolutional neural network, and decoder should also be a convolutional neural network, as both input and output deals with what, images, right? And when it comes to text, see, you have a question, are you free tomorrow? And in the output layer, we have to create, yes, WhatsApp, right? So here, what is the input? Text. And what is the output? That is also text, right? And text is actually having which kind of dynamics? Temporal dynamics. And the output is also text. There also temporal dynamics. And to handle temporal dynamics, you can make use of any RNN family, right? That is LSTM or GR, any kind. So the encoder is also a RNN, and decoder is also an RNN. Okay, hope you got the idea, right? So with encoder decoder model in vision, we can create different generative AI techniques. See, input image can be converted into semantic, instance, and pantopic segmentation. Noise image to denoised one. Okay, and one image in a low resolution to high resolution, black and white image into color images. And even in the case of text, we can convert from one language to another language, one bigger text to smaller text, then a question to answer. So all these things can be done using encoder decoder model. And mostly if you are using LSTM, the encoder will be an LSTM, decoder will also be an LSTM. Okay, even we can actually make use of this encoder decoder model for an text and vision application. Okay, see here, image input is an image, right? And output is a text. So this process is called as image captioning. Now, can you just think about what kind of encoder decoder model can be used? The input is image, which is spatial in nature. The output is text, which is temporal in nature. So, anyone can you tell me what kind of encoder decoder model we can use? What should be the kind of neural network in the encoder, and what should be the kind of neural network in the decoder? Those who are listening very carefully can answer it very simply.
Convolutional
Yes, a convolutional encoder.
and RNN decoder.
Exactly, RNN decoder, right? You can actually simply think of it. And can you just think about this visual question answering? It is having an image and a text as an input, and the text as an output. Image and a text as an input, and text as an output. See, an image will be there. Who is wearing the glass? The answer will be man. So, can you tell me what kind of encoder can be used? What kind of decoder can be used? In the encoder part, the input is both image and text, right? So
Combination.
yeah, it's a spatial data and temporal data. So
Temporal.
we make use of a CNN and RNN encoder fusion and a RNN decoder, right? Exactly. So hope you understood how it can be generated, right? And the second kind of neural networks are like a generative adversarial network. Mostly it is used for images, but we can actually flexibly design this kind of neural network for text too. Okay. So what is this like generative adversarial networks are working? It is like a game between a police and a thief. Okay, so generator is a network. Okay, generator is a network which act as a thief, and discriminator is a network which act as a police. So the ultimate aim of generator, the thief, is to fool the discriminator. And what is the advantage of fooling a discriminator? Then the thief can generate fake data which is very much similar to real. And what is that is our need. That is the adversary, the generator should be able to generate something which is very particular to seems like a real, right? For that they are actually using a gaming strategy. So for that, first it will start generating some fake.
Sir,
And
sorry to interrupt.
yeah,
Jaya ma'am has raised a hand. So over to you, Jaya ma'am. If you have any query,
So
Jaya
how
ma'am.
autoencoders can be used in compression, like any
yeah, ma'am.
application regarding to?
Ma'am, we can answer that question in connection with the previous one in the question answering session. Okay, is it fine?
Yes, sir.
Yeah. So, what is happening is the generator will start generating fake, and that fake will get exposed to the discriminator, and discriminator is powerful enough to identify the fake, right? So it will detect it as fake, and on getting that feedback, the generator will will change its strategy to generate fake, and again it will expose to the discriminator, and discriminator again will find it as fake, and after several iterations the generator will change the strategy one by one, and ultimately the generator can come up with a strategy which can make fakes which is very similar to real. Then at that time discriminator will get confused and will not be able to identify the fake as fake. It will automatically classify them as real. So at that process, what will happen? At that point, what will happen? The generator is now powerful to fake the discriminator. So our need is actually achieved. Okay. So this kind of techniques can also be applied for textual data for building different models. Okay. And the other kind of model that changed the the phase of NLP is actually called as transformers, and it is actually introduced in 2019 in a paper titled as "Attention is All You Need." Okay, attention is all you need, and this attention is all you need is describing another kind of neural network, which is also an encoder decoder model. Okay, encoder decoder model, but uses a special mechanism called attention rather than recurrence. Okay, there is no recurrent connections. Here it uses a mechanism called attention. Okay, so with that attention, it will generate some representation at the encoder, and that representation can be given to the decoder. Okay, and the advantage, one of the difference between the simple encoder decoder model and the transformer model is in the encoder decoder model we are able to use that encoder and decoder as a single unit for training it, right? But that in transformers we can use this encoder decoder as a separate encoder, a separate decoder, and a together encoder decoder. If you're using the encoder alone, it is called as BERT, BERT, BERT. Okay, and if you are using the decoder only, it will be used as what? GPT, generative pre-trained transformer. Okay, and if you're using it together, it is called as T5 architecture. Okay, T5 architecture. So the BERT is actually used to create a kind of embeddings, and then you can use that embedding for classification or any other machine learning task. But the GPT is actually a language model, and language model, a language model is nothing but it is capable of predicting the next word for a given set of a given sequence of word, right? So for training the input model, for training the bird, we are using or we call it as a mass language model, and we use a technique called missing word prediction strategy. And for training the GPT, we are using the next word prediction strategy. Okay, so this GPT, that is the decoder part of the transformer, is actually called as large language model, LLM. And why it is called as large language model? Because of the large number of parameters within the model, as well as the huge amount of internet data which is used to train the model. That is why it is called as a large language model. And the secret behind that large language model is nothing but, or the chat GPT is nothing but this kind of LLMs are there. Okay, and the vision transformers are the computer vision counterpart of uh, transformers. As I said, transformers are actually designed for textual data processing, but here the the image part can be tackled with vision transformers, and this is the path or the timeline of the chat GPT. Like we started with transformers, GPT, GPT-2, GPT-3, instruct GPT, GPT, chat GPT, and we are now having the model chat GPT 5.0, right?
Uh,
And
Shailesh sir,
yeah,
in between a quick reminder on the timing
yes, 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 ma'am.
so that we can
About
wind up on time.
it's
Okay,
about
it
it's
will be
about to
okay.
complete.
Oh,
Yeah.
okay, sir.
So the last kind of models are actually called as diffusion model, which uses the diffusion architecture for generating the contents. Okay, and this is actually used by the application DALI and Sora for generating images and videos, artificial, the AI videos and AI images. I'm not explaining this much as it is not concerned with the textual data. Okay, and finally, what all things that we can now perform in the domain of NLP, that is with large language model. We have a big scope in the areas of prompt engineering, fine tuning, and reinforcement learning. And these techniques, that is prompt engineering, retrieval augmented generation, and fine tuning, are the hot topics currently happening in the NLP domain, and open up a big arena for research. Okay, so thank you for patiently listening for this much time. I hope the explanations was clear to you, and we have few questions we can discuss on that. Uh, so what was the first question? There was a question in the chat box, right? Sir was discussing an example which cannot use ML to solve. Can you please explain? Is that about the lottery draw? I think Naomi.
I
No.
think I think that was the example you have mentioned, lottery draw
Yeah,
example.
yeah. Lottery draw is a particular example that I quoted for as for not suitable for solving with machine learning. Why it is not suitable is, see, there is an uncertainty in the nature for the lottery draw, but still we cannot find a hidden pattern within that data. See, suppose you are having 100 lottery draws for last 100 days. Will you be able to find that any pattern in that? It is completely random, right? That and complete random process, and that randomness itself is not having any kind of hidden pattern. That is why I mentioned it as not solvable by machine learning. Hope it is clear, right?
Yes, sir. Yes.
Yeah.
Thank you.
Yeah. And what about that another question? Autoencoder used in, yeah. Autoencoders are particularly used for compression, ma'am, because see, there is a kind of autoencoder which is called as associative autoencoder. Okay, and in associative autoencoder, what is happening is we are giving an input to the encoder, and we are generating some output, right? And that output is again compared with the actual input for reducing the loss. So the input will get reduced into a smaller dimension, a smaller space, and from that it is able to generate the output, the real input. Okay, output as the real input back. Okay, so what is the advantage? If you have the intermediate representation of your actual data, the decoder is capable of representing, regenerating the actual output, right? Decoder is able to generate the actual output back. So suppose you are setting up a communication system, and you want to send the data. What you can do is, if you have a large data, use that large data in the encoder. So encoder will give you a smaller representation, right? And that smaller representation can be transmitted over the channel, and on receiving the input at the receiver side, that data can be again passed through the decoder. Then decoder can actually generate the actual one. And the one thing you have to keep in mind is there will be a small loss in the generated output, and that is compromisable. Then you can use this encoder decoder architecture as a compression technique, which is particularly a lossy compression technique. Is that clear? Yeah, exactly. This is sparse recovery. And really make use of we can actually architect this thing as a lossless tool, what we can do is by taking the by taking the intermediate representation, okay, by taking the intermediate representation, we can also take the difference between the output and the actual input and keep that vector along with the code. Then you can actually generate the output back exactly as that of the same input.
Any other hand raise? I could see one more person. Sir, please ask. Krishna's. Can autoencoders can be used for hardware modeling? If you could explain it briefly.
Yeah, I have seen some examples for generating the PCB models. I don't know whether you are thinking about the PCB designing or something like that, uh, particularly on this hardware modeling. So this kind of PCB modeling that optimizes the utilization of space and number of transistors, the number of components can be designed with this autoencoder. I have seen that application in some papers. I have not tried it, but I have seen that in some uh, literatures.
Okay, sir. Any queries from the participant side?
See, this generative models and transformer models are now doing it well, uh, outcome with this technicizing. I have got one paper for review from one of the prominent journal which deals with the same topic, hardware modeling.
Okay, sir. Is there any more queries? Otherwise, we can wind up. Okay. Good evening. Thank you so much, Shailesh, sir, for your wonderful and insightful session on fundamentals of NLP and generative AI. We truly appreciate the way you explained each concept with such clarity and depth. On behalf of all the participants and the organizing team, I express our sincere gratitude for taking the time to share your expertise with us. It has definitely added great value to our FDP. Thank you once again for your valuable contribution, sir.
Thank you, ma'am.
Sir, as a token of gratitude from our institution, we would like to present a virtual memento from our site.
Yeah. So anybody need any kind of support or any kind of uh, doubt clarification, you can connect with me in LinkedIn. Okay, you can search for Dr. Shailesh Sivan, and it will be useful for you to. And as I'm sharing a lot of resources on this new topics.
So, thank you, Dr. Shailesh, for sharing his wonderful insights on the fundamentals of NLP and generative AI. Thank you so much, sir.
Thank you.
This is a token of gratitude from TocH.
Yeah, thank you for inviting me for this. It's a big event.
So, dear participants, coordinator, can you just stop recording and restart it for the next session? Participants, kindly wait.